Infinite Realities, The Science and Possibility of Parallel Universes, by David Rousseau. Introduction. I was speaking with a doctor one afternoon when our conversation drifted toward a subject that felt as philosophical as it was scientific. Parallel realities. He paused for a moment and said something that stayed with me. Right now, he said, there could be another version of me somewhere else, maybe sitting on a beach, holding a drink and watching the ocean. In another reality, that might already be happening. At first it sounded like science fiction. The idea that another version of ourselves might exist somewhere, living a slightly different life, making different choices, experiencing another version of reality seems like the kind of speculation reserved for novels or late-night thought experiments. Yet modern physics has begun to take ideas like this surprisingly seriously. What if our universe is just a single thread woven into a far larger cosmic fabric? What if beyond the reality we perceive exist innumerable others, each with its own laws, histories, and alternate versions of ourselves? These questions are no longer purely imaginative. They arise from genuine scientific inquiry at the crossroads of physics, cosmology, and philosophy. The roots of these ideas stretch back decades. In the 1950s, physicist Hugh Everett III proposed the many worlds interpretation of quantum mechanics, suggesting that every possible outcome of a quantum event actually occurs each in its own branching universe. Around the same era, cosmologists such as Stephen Hawking explored the nature of black holes and the origins of the cosmos, revealing a universe far stranger than intuition might allow. In more recent decades, physicists like Max Tegmark have organized these ideas into structured models of the multiverse, describing levels of reality that range from distant regions of our own space to entirely different mathematical universes. While these theories remain speculative, they emerge naturally from equations that successfully describe our universe. The same physics that explains atoms, stars, and galaxies sometimes leads scientists to astonishing conclusions. Our universe might not be alone. This book invites you to explore these infinite realities through a scientific lens. Each chapter examines bold hypotheses grounded in modern physics, from cosmic inflation, which may have produced countless bubble universes, to quantum branching that could create endless versions of you. Along the way, we encounter profound philosophical questions. What does existence mean if multiple versions of ourselves populate different realities? Could there be universes where the laws of nature differ entirely from our own? And if every mathematically possible universe exists somewhere, what does that say about the nature of reality itself? Infinite Realities is grounded in science, but open to wonder. The multiverse stretches the imagination while challenging our understanding of identity, choice, and existence. Even if we never directly observe another universe, contemplating their possibility expands our intellectual horizons and deepens our appreciation for the extraordinary cosmos we inhabit. The universe we know may only be the beginning. Chapter 1. The Birth of the Multiverse. The idea of multiple universes might seem like a modern invention or the stuff of science fiction, but its origins trace back to humanity's earliest fascination with the cosmos. For centuries, the universe was assumed to be singular, a grand but finite stage governed by universal laws. As 20th century physics advanced, this certainty began to erode, giving rise to the concept of a multiverse. Quantum mechanics, the science of the infinitesimal, provided the first hints. At atomic and subatomic scales, particles behave in ways that defy common sense. They can exist in multiple states simultaneously, only settling into a definite state when observed. This led to a provocative question. If the quantum world is inherently probabilistic, could every possible outcome exist in separate, parallel realities? This insight laid the foundation for Hugh Everett III's many worlds interpretation. Yet quantum mechanics was only part of the story. Cosmology, the study of the universe on its largest scales, offered another clue: cosmic inflation. In the early 1980s, Alan Guth suggested that just after the Big Bang, space expanded exponentially, faster than the speed of light. This not only explains the uniformity of the cosmos, but also hints at a staggering possibility. Inflation may be eternal, producing countless bubble universes. each with its own distinct laws and histories. Together, these insights suggest a revolutionary vision. Our universe may be only one among an infinite ensemble. Quantum mechanics points to branching realities on the tiniest scales, while cosmology implies vast, disconnected universes on the largest. Combined, they challenge our most fundamental notions of existence. Physicists approach the multiverse cautiously. It is not pure conjecture. It emerges naturally from equations that experiments and observations support, yet the implications extend far beyond physics. If multiple universes exist, our ideas of identity, free will, and meaning are transformed. Every choice you make could be mirrored elsewhere. Every star, planet, and law of nature might have a twin or a dramatic contrast somewhere beyond reach. By chapter's end, the multiverse stands as both a scientific and philosophical reality. From subatomic particles to cosmic expanses, its birth invites us to envision a reality without boundaries and perhaps an infinity beyond. Chapter to the Infinite Universe. Imagine standing atop a hill at night, staring into a sky dotted with stars. Each distant point is a sun, many with orbiting worlds. Now picture that this view never ends, not after billions of light years. Not ever. Space stretches indefinitely, and with true infinity comes extraordinary and almost unsettling possibilities. The concept of an infinite universe is not new. Philosophers and mathematicians have grappled with infinity for centuries. Modern physics gives it concrete implications. If space is boundless, then every possible arrangement of matter, every galaxy, planetary system, and star formation will eventually repeat. Somewhere beyond our observational horizon, a solar system identical to ours almost certainly exists. On that distant world, a version of you may be living a life indistinguishable from your own. This is the essence of Max Tegmark's Level 1 multiverse. These universes are not governed by different laws. They are merely regions so distant that interaction is impossible. Beyond the observable cosmos, matter arranges itself in all conceivable patterns. Somewhere, you are reading this. Elsewhere, another you is making different choices, living elsewhere, pursuing another path, or never encountering the multiverse at all. The consequences are profound. If all possibilities occur somewhere, what does uniqueness mean? Are we exceptional, or just one thread in an infinite tapestry? And yet, there is a certain reassurance. Every path not taken, every decision deferred, is unfolding somewhere in the cosmos. Infinity also reshapes our understanding of probability. Events that seem improbable in a finite universe happen inevitably in an infinite one. This challenges notions of chance, destiny, and the scale of existence itself. Grounded in physics, the Level I multiverse offers a scientifically plausible glimpse of infinity. It reveals a cosmos not merely vast, but unimaginably immense, mirror reflecting all possible realities, including countless versions of ourselves. Chapter 3. The Many Worlds Interpretation. In a Level 1 multiverse, copies of you exist across space, repeated in distant regions of an infinite cosmos. But what if alternative versions could arise here and now, not because of distance, but through the very fabric of reality itself? This is the revolutionary idea behind Hugh Everett III's Many Worlds interpretation of quantum mechanics, proposed in 1957. Quantum mechanics is famously counterintuitive. Particles can exist in multiple states at once, a condition called superposition, and only collapse into a definite state when measured. The Copenhagen interpretation suggests that observation forces a single outcome. Everett imagined a bolder alternative. What if the universe never collapses? What if every potential outcome unfolds in its own branch? Every quantum event, an electron flipping, a photon scattering, a decision you make creates a divergence. In one branch, you sip coffee. In another, tea. In one, you accept a job. In another, you decline. Each choice generates a new universe where every possibility plays out. This interpretation emerges directly from quantum mathematics. The Schrödinger equation progresses deterministically, without a mechanism to select a single outcome. Everett's insight: all possibilities coexist, forming an endlessly branching multiverse. The implications are staggering. Other versions of you may live in different cities, pursue alternate careers, or experience entirely different emotional lives. Identity itself becomes fluid. You are one of countless iterations, each equally real. Philosophical questions follow naturally. If every choice spawns a new reality, what does moral responsibility mean? Do regrets matter if another you lives the alternatives? And what does existence mean when countless versions of yourself inhabit an infinite quantum multiverse? The many worlds interpretation transforms the multiverse from a distant abstraction into an intimate reality. Life is no longer a single narrative but a sprawling tree of infinite branches, with you at the root each branch real, alive, and reflecting the limitless possibilities of existence. Chapter for a Bubble Universes. If the many worlds interpretation shows us the multiverse in the quantum realm, cosmology reveals an even stranger possibility: universes that are entirely separate from ours, with their own laws of physics, constants, and realities. These are the bubble universes, the offspring of eternal cosmic inflation, and they invite us to imagine worlds that are not just parallel, but fundamentally alien. The story begins with Alan Guth's theory of cosmic inflation. According to this idea, in the first tiny fraction of a second, the Big Bang, the universe expanded exponentially, stretching space itself faster than the speed of light. But in some versions of inflation theory, this process is eternal. While one pocket of space stops inflating and forms a universe like ours, other regions continue to expand, eventually spawning their own bubble universes. Each bubble is a cosmos in its own right, potentially with different dimensions, particles, or forces. Unlike Level 1 multiverse regions, these bubble universes may not share the same physical constants. Gravity could be stronger or weaker. Chemistry might be entirely different, making carbon-based life impossible, or perhaps allowing forms of life we can scarcely imagine. A universe could be dominated by dark energy, have no stars at all, or contain exotic matter that never appears in our cosmos. Some might be chaotic, violent, or inhospitable, while others could be surprisingly similar to our own. The concept is as mathematically compelling as it is philosophically unsettling. In some bubbles, the cosmos may have formed in a way that mirrors ours, producing galaxies, stars, and planets much like Earth's. In others, the Big Bang might have created entirely unfamiliar landscapes, governed by physics that make our universe seem trivial in comparison. Every bubble is a laboratory of possibility, showing that the laws of nature themselves are not fixed, but contingent, a product of cosmic happenstance. Bubble universes also shift our perspective on fine-tuning. The constants of physics in our universe seem remarkably suited for life, a fact that has puzzled scientists for decades. In a multiverse filled with bubbles, fine-tuning becomes less mysterious. If countless universes exist, it is unsurprising that at least one has the precise conditions necessary for stars, chemistry, and life to arise. We live in the universe that permits our existence, not necessarily the only possible universe, but the one where observers like us can emerge. These ideas stretch beyond science into wonder and philosophy. Bubble universes are realms where imagination becomes plausible, where the impossible becomes real. They remind us that reality is not confined to what we see, or even what we can measure. Beyond the edges of our observable cosmos, new worlds bubble into existence, each with its own story, each expanding the boundaries of what it means to be a universe. Chapter 5. Universes inside black holes. Black holes are among the most mysterious objects in the cosmos, regions where gravity becomes so intense that not even light can escape. They challenge our understanding of space, time, and reality itself. But what if black holes are not merely destructive? What if they are cosmic wombs, giving birth to entirely new universes? This is a bold hypothesis explored by physicists, inspired by the work of Lee Smolin and others, a theory that bridges black hole physics, cosmology, and the multiverse. At the heart of a black hole lies the singularity, a point where matter is compressed to infinite density and the known laws of physics break down. Classical general relativity predicts this extreme, yet quantum mechanics suggests that the singularity may be more complex, potentially smoothing out into a gateway to another space-time. In Smolin's cosmological natural selection idea, each black hole could spawn a new universe inside it, with slightly different physical constants than the parent universe. In effect, every black hole could be a seed, producing offspring universes in a vast cosmic lineage. Imagine it. The stars we see in our night sky may one day collapse into black holes, each giving rise to a universe entirely separate from ours. Perhaps the Big Bang itself was the birth of our universe from the interior of a black hole in apparent cosmos. If true, our universe would be one bubble in a chain of universes, connected not by space, but by a hidden generational thread stretching through black holes across cosmic time. The implications are both scientific and philosophical. Black hole universes could explain why our physical constants are just right for life. In a multiverse where universes reproduce through black holes, those universes that support star formation and black hole creation would naturally dominate. It is a cosmic version of evolution, but on a scale and with mechanisms far beyond life as we know it, beyond physics. These ideas challenge our perception of existence. If a universe can grow inside a black hole, it reframes our understanding of creation, causality, and even destiny. The black holes scattered across our universe may not merely destroy, they may be the engines of creation, each harboring realms of possibility we can only begin to imagine. In contemplating universes inside black holes, we are forced to confront a humbling thought. The cosmos may be far larger, stranger, and more creative than we can perceive. Our universe may itself be the child of a collapsed star in another reality. And if black holes can birth new universes, then every point of extreme gravity in our cosmos may conceal a secret, a doorway to worlds beyond our own, quietly expanding the boundaries of existence. Chapter 6. The Perfect Universe. Among the many ideas of the multiverse, one stands out as profoundly human: the search for a perfect universe, a cosmos where life flourishes effortlessly, where the laws of physics align in exquisite harmony, or even one optimized for happiness rather than mere survival. This chapter explores what it would mean for a universe to be perfect, drawing on science, philosophy, and the subtle logic of the anthropic principle. The fine-tuning problem is the starting point. Our universe is governed by Congstong's numbers that dictate the strength of gravity, the mass of particles, and the behavior of forces. Change any one of these slightly, and stars might never form, chemistry could fail, and life as we know it would be impossible. The constants seem astonishingly precise, as if the universe were calibrated for the emergence of observers like us. Physicist Brandon Carter introduced the anthropic principle to grapple with this mystery. In its simplest form, it states that we observe the universe the way it is, because if it were different, we wouldn't be here to notice. In other words, our universe isn't necessarily designed for life, it is simply one among many possibilities, and we find ourselves in a universe that supports our existence. Yet the anthropic principle opens the door to imagining universes, intentionally or naturally, tuned to perfection. What would a perfect universe look like? Perhaps it is optimized for life itself, maximizing the emergence of planets, ecosystems, and conscious beings. Perhaps it is optimized for happiness, minimizing suffering while enabling joy, creativity, and connection. These are not questions science can answer definitively, but physics and cosmology provide a framework to explore them. In a multiverse filled with countless bubble universes, some may naturally possess conditions far more conducive to life than our own. Some may even host laws of physics that allow forms of life or intelligence beyond our imagination. Philosophically, this concept is both exhilarating and unsettling. If perfection exists somewhere, it challenges our ideas of morality, meaning, and purpose. Are we living in a near-perfect universe? Or is perfection an abstract ideal that exists only in other realities? And if we can imagine a universe optimized for human well-being, does that make our own universe less special? Or does it highlight the rarity and, thus, the wonder of our existence? The idea of a perfect universe reminds us that the multiverse is not merely a scientific concept, it is a canvas for human curiosity and reflection. By contemplating universes optimized for life or happiness, we explore not only the cosmos, but our own values, desires, and potential. In the vast ensemble of realities, perfection may be a fleeting possibility, but the pursuit of understanding it illuminates both the universe and ourselves. Chapter 7: Dream Universes. What if some universes exist not just in physics, but in thought? What if there are realities where the rules of existence bend to imagination, where the boundaries between possibility and desire dissolve? These are the dream universes, realms that stretch the multiverse concept into the territory of consciousness, simulation, and the mind itself. The idea has philosophical roots in the simulation hypothesis, popularized by thinkers such as Nick Bostrom. Bostrom suggested that advanced civilizations might create highly detailed simulations of reality, indistinguishable from real existence. If this is possible and if they create enough simulations, then it becomes statistically likely that what we perceive as reality might itself be a simulated universe. Extrapolating further, there could be infinite simulated universes, each with its own rules, histories, and outcomes, coexisting alongside physical realities. Dream universes need not be digital. Consciousness itself may shape the fabric of reality in ways we do not yet understand. Quantum mechanics hints at a strange interplay between observation and outcome, and some theorists speculate that in certain multiverse scenarios, universes could exist that reflect or amplify conscious thought. In such a universe, what you imagine could literally manifest. Your dreams could become reality, and your mind could be an architect of worlds. These universes raise profound philosophical questions. If a universe exists where every dream is fulfilled, what does that mean for desire, choice, or motivation? Could the fulfillment of all possibilities reduce meaning? Or does it expand it by demonstrating the vastness of potential existence? And if our reality is just one among countless dream universes, are the laws of physics universal, or merely local rules in a landscape shaped by observation, consciousness, or computation? From a scientific perspective, dream universes remain speculative. We have no empirical evidence for them, and their mechanics, if they exist, would likely transcend the physics we know. Yet their possibility invites us to explore the edges of reality, where science meets philosophy and imagination, becomes a legitimate lens for understanding existence. Dream universes remind us that the multiverse is not only a story of stars, particles, or physics. It is a story of mind, creativity, and perception. In these realms, the impossible becomes possible, and the limits of our world dissolve into the infinite. They challenge us to ask, what is reality? And what is the role of consciousness in shaping the cosmos? Perhaps somewhere, in a universe beyond our own, the answers are already playing out in a reality sculpted by thought itself. Chapter 8: Instantaneous Universes. Time is something we take for granted. We measure it in seconds, minutes, and years, and we experience it as a steady progression, past, present, future. But modern physics has shown that time is far from absolute. Albert Einstein revealed in his theory of relativity that time is flexible stretching near massive objects, slowing down as we approach the speed of light. Quantum mechanics adds a layer of mystery, with phenomena like entanglement where particles seem to instantaneously affect each other across vast distances. Together, these insights hint at the possibility of instantaneous universes, realities where time flows differently or perhaps doesn't flow at all. Imagine a universe where every moment exists simultaneously. Birth and death, joy and sorrow, cause and effect all are coexisting, accessible in a single sweep of reality. Or consider a universe where events we experience as slow, like the growth of trees or the formation of galaxies, occur in an instant. In such a world, the past and future are not sequential. They are layered, overlapping, and perhaps even observable all at once. Quantum entanglement provides a tantalizing clue. To particles, no matter how far apart, can remain correlated in a way that seems to defy the limits of time and space. If this phenomenon hints at a deeper truth, then some universes could operate under rules where information or events propagate instantaneously, where time as we know it is a local illusion rather than a universal constant. The consequences of such universes are profound. Inhabitants might experience reality as a perpetual now, where choices and consequences are inseparable. Memory, causality, and experience could function in ways that challenge every assumption we make about life and consciousness. Even fundamental physics might be radically different, allowing processes we consider impossible: instantaneous communication, immediate travel across vast distances, or simultaneous occurrences of mutually exclusive events. Instantaneous universes remind us that the multiverse is not merely about more worlds, but about more ways of existing. Each universe could bend the dimensions of reality itself, redefining time, space, and possibility. By exploring these universes, we confront a truth both humbling and exhilarating. What we perceive as fixed the flow of time, the order of events may be just one small sliver of a vastly richer cosmic landscape. In some universes, the future and past may coexist. The impossible may unfold instantly, and the familiar rules of existence may be entirely rewritten. Chapter 9: The Mathematical Universe. What if the multiverse is not limited by space, time, or even the physical laws we know? What if reality itself is, at its core, mathematics? This is the radical idea behind Max Tegmark's level for multiverse, sometimes called the mathematical universe hypothesis. The concept that every mathematically possible universe exists, whether or not it resembles our own. In simpler multiverse models, universes differ in physical constants, dimensions, or branching outcomes of quantum events, but Tegmark's level for universes are broader. They include all possible realities that can be described mathematically. If a consistent set of equations can exist, then a universe governed by those equations exists somewhere. Some may resemble our own cosmos. Others may be so alien that they defy comprehension, with entirely different structures of space, time, or logic. This idea stretches imagination to its limits. A level for universe could have different numbers of spatial dimensions, different mathematical foundations, or even entirely novel forms of physics that cannot exist in our universe. In sum, the concept of matter or energy may not exist as we know it. In others, cause and effect could be replaced by rules entirely unfamiliar to human thought. Every logically consistent reality is realized. Every possible set of equations spawns a universe. The multiverse, in this sense, is infinite not just in number but in kind. The implications are staggering. For one, level for universes make every conceivable reality inevitable. Worlds where magic-like phenomena exist, worlds where consciousness takes forms beyond imagination, or even worlds where the rules of logic themselves are different. Every possible dream, theory, or mathematical construct has its own universe somewhere in the multiverse. If we can describe it, it exists. Philosophically, this raises profound questions about meaning, uniqueness, and existence. Are we special, or are we just one pattern among an infinite set of mathematical realities? Does existence matter if every conceivable world is realized somewhere? And yet, level for universes also inspire awe. They suggest a cosmos where the limits of imagination are no longer constraints, but guides to the richness of reality. The mathematical universe shows that the multiverse is not merely vast. It is limitless in principle and structure. Our universe, with its stars, galaxies, and conscious beings, is just one mathematical pattern among an infinite ensemble of possibilities. In exploring these universes, we confront the ultimate scope of reality. A multiverse where anything that can exist mathematically does exist, and where every idea, every equation, every imagined world has a home. Chapter 10: Identity Across Universes. The multiverse challenges not just our understanding of reality, but our understanding of ourselves. If infinite versions of the cosmos exist, some similar, some radically different, then there are also infinite versions of you. Every choice you have made, every path not taken, is realized somewhere. But, if countless yous exist, what does it mean to be you? Consider the many worlds interpretation, where every quantum decision creates a new branch of reality. In one universe, you pursued a particular career. In another, you chose a different path. In the Level 1 multiverse, distant regions of infinite space contain duplicates of you living lives, identical or nearly identical to your own. And in Tegmark's level for multiverse, there may be versions of you governed by entirely alien mathematics or physical laws. Across these realities, identity becomes fluid, plural, and profoundly complex. Philosophy and neuroscience offer some insight. From a scientific perspective, identity is tied to memory, continuity, and consciousness. You are the accumulation of your experiences, shaped by the flow of cause and effect in this universe. But if there are countless other versions of you with different experiences, the self is no longer unique. Does that diminish your significance? Or does it expand it? Perhaps you are simultaneously many, connected across realities by shared origins, yet diverging in ways that create infinite narratives. Moral and existential questions follow naturally. If an alternate version of you makes different choices, who is responsible for the outcomes? If versions of you experience every possibility, what does that mean for free will? Some philosophers suggest that our sense of morality and purpose may depend on embracing the self we experience here, rather than the selves we cannot perceive. Others argue that recognizing infinite versions of ourselves can foster empathy, humility, and a deeper understanding of possibility. The multiverse also invites reflection on uniqueness and meaning. Even if countless duplicates of us exist, each version lives a subjective reality that feels real. Your consciousness, anchored in this universe, remains singular in experience. The existence of infinite yous does not erase your reality. Instead, it situates it within a grand tapestry of possibility, where each thread, each version of self is a testament to the richness of existence. Ultimately, identity across universes teaches us a paradoxical lesson. We are both ordinary and extraordinary. Ordinary, because in an infinite cosmos, our patterns repeat endlessly. Extraordinary, because our lived experience, the thoughts, choices, and awareness that define us remains uniquely ours. In the multiverse, the question is no longer merely who am I, but who are we collectively, across all realities. And in contemplating that question, we glimpse the profound beauty and mystery of being alive in an infinite, ever-branching cosmos. Conclusion: the power of parallel universes. Throughout this journey, we have traversed the infinite, from the distant stretches of space in the Level 1 multiverse, to the branching quantum realities of many worlds, to the mind-bending reaches of the mathematical universe. We have imagined universes born in black holes, shaped by consciousness, or unfolding instantaneously. Each chapter has revealed not only the scientific possibilities, but also the philosophical and human questions these ideas provoke. The multiverse is a lens through which we reconsider our place in reality. It challenges the notion of uniqueness, suggesting that countless versions of ourselves and our universe may exist. Yet it also magnifies the wonder of existence. Even amid infinite repetition or radical difference, our experience here, the choices we make, the lives we touch is uniquely ours. Science tells us what is possible. Imagination and philosophy help us grasp what it means. By contemplating parallel universes, we confront the limits of knowledge and the scope of human curiosity. Physics provides the equations and observations, cosmology maps the stars, and quantum mechanics traces the branching pathways of reality. But the multiverse is not merely a scientific hypothesis, it is a framework for thinking about life, identity, morality, and meaning in ways we never could within the confines of a single universe. Whether or not we ever find empirical proof of parallel worlds, the concept itself has already reshaped our understanding of existence. It invites humility, encouraging us to recognize the vastness beyond our perception, and courage, inspiring us to explore ideas that stretch the mind. It is a reminder that reality is far stranger and more magnificent than we imagine, and that our curiosity, imagination, and wonder are as boundless as the universes we contemplate. In the end, the multiverse is both a scientific possibility and a mirror for the human spirit. It urges us to think bigger, question deeper, and dream wider, whether we ever step foot in another universe or remain bound to this one. The idea of parallel worlds has already expanded the boundaries of thought, and in doing so, it has forever changed how we see ourselves, our choices, and the cosmos we call home.